Hello everybody. So we are going to now start with the first method, which is the solution of the equations simultaneously. And as we agreed last time that we have a system that has enough information but no unit can be solved with the given information, so we have to find a way to calculate the unknown variables. And according to what we have here, again, I mentioned this last time, but this is a point that's very, very important here. We have 20 variables, 3 of them are known or given, so there are 17 unknown variables, and we have 12 equations and 5 additional relations, which are all together are 17 equations. So I have 17 equations and 17 unknowns, so we can use these equations to find the unknown variables. So what I have here is the list of the 17 equations. This is the balance on the mixer. I'm not going to go through all of them, but just to make it clear for you, what are these? So this is the number of moles of ethylene in stream 2 minus number of moles of ethylene in stream 4. So this is ethylene in 2 and 4 equals the ethylene in the feed. The same for the reactor. These are the equations for the balance on the reactor using the extent of reaction method. These are the equations for the separator, the mass balance on the separator for the 4 components. So we have, if we go back, we have here 4 equations for each one of them, which are these 4 times 3. And we have the additional relations. We have 4 for the separator and 1 for the reactor. These are 1 for the reactor, and these are the 4 for the separator. So these are 17 equations and 17 unknowns. And in order to solve these equations, you can try to solve them manually, which is going to be a hassle because you need to spend a lot of time to find which equations from these 17 equations that you can start with, and then if you can find 2 equations that you can solve simultaneously to get the unknowns in these 2 equations, and then you can substitute in the rest. But this is going to be almost impossible because I don't think you can find 2 or 3 equations and 3 unknowns that you can solve manually. So the other option is by looking at these equations, you will notice that they are all linear algebraic equations, meaning that the coefficients of all the variables are constants and the powers are 1. So this is number of moles of ethylene in stream 2 power 1 with a coefficient of 1, so it's constant, minus 1 multiplied by this. So this applies for all of them. So one way we can solve a system of linear algebraic equations is by matrices. So what I did is I wrote all these equations, but I put them in a form of a matrix, which is what you see here. I know it's a very, very big matrix. It's 17 rows and 17 columns. And for those who are not aware of this or forgot how this works, the equation is one line multiplied by the column produces the first cell in the column, in the products column. So if you multiply this by this, so it's 1 multiplied by Ne2, and then we have negative 1. I'm not sure which one of this. I think it's going to be Ne4 if I'm not mistaken. It's going to be 1000. So this is this equation. So this is 1 minus 1 Ne2 minus Ne4 equals 1000, which is this equation. And the same, I did this for all the 17 equations. And this is just another way of solving this problem. So what we want to get at the end of this is this variables matrix. So this is the coefficients matrix, this is the variables matrix, and this is the product matrix. And there is a very famous way of doing this calculation. It's not simple, of course, but it's a known mathematical way, which is writing the equation as A multiplied by X equals B. So A is the coefficient matrix, X is the variables matrix, and B is the product matrix. And if we multiply by A power minus 1, then it's going to be A power minus 1 multiplied by A, which will be the identity matrix, which is 1. Multiplied by the X, which is what we want to calculate, the unknown variable, equals a power minus 1 times b. So we can find all the unknown variables by multiplying a power minus 1, which is the inverse of the matrix, by b. So this is something that we can do manually, but it will take forever if you want to do this manually, and the possibility of doing mistakes in this is endless. So you can do a lot of mistakes, and most probably if you spend a lot of time trying to do this, you will not be able to do, or you will do a lot of mistakes, and finally you will not get the result that you want. And even if you can, it will take a lot of time. Also, you want to make sure that the matrix has an inverse, because there are matrices that don't have inverses. This happens if there is one of these equations here that is dependent on the other. So if, for instance, I write an equation 1 minus 1, and I write here 2 minus 2, it's going to have one equation repeated twice, so it's not going to be 17 equations and 17 unknowns, it's 16 equations and 17 unknowns, so this is not going to work. So there are a few things that we want to check. First is this matrix, we call it a singular matrix. That means that it has an inverse. If it doesn't have an inverse, it's called a non-singular matrix. And what we can do to know this is by calculating the determinant of the matrix. And if we can calculate the determinant, if it's 0, then the matrix has no inverse. If it is not 0, then the determinant has an inverse. So this is the first step, or first thing. The second thing is to calculate the inverse. Third thing is to multiply the inverse by b. And this is a very, very long process if you want to do this manually. However, luckily we have now software that we can use to do these calculations in few minutes, or maybe 1 minute or 2. So this is what I'm going to show you now. I will do this calculations on Microsoft Excel. So I already put the matrix here. All these gray cells here are the cells for the, so this is the matrix, it's 17 times 17. This is the product matrix, which is this 1000, 1000, 0, 500, and the rest are zeros. 1000, 1000, 0, 500, and the rest are zeros. So this is the product matrix. This is the coefficients matrix. It took me some time to write the coefficients and make sure that we have nothing missing here, or there is something wrong. But at the end of the day, this is the matrix that we have. I tried to make it more detailed here a little bit. Of course, it's a matrix at the end of the day, but I put these as the equations for the mixer. This is the first additional relation. This is the reactor. This is the separator, and this is the separator additional relations. And here we have 17 coefficients for or the coefficients of the unknowns. So these correspond to NE1, NB2, EB2, and or NE2, and so on. So I have them for all the components. So let's start with the first thing, which is calculating the determinant. The determinant here is it's something that we can do in Microsoft Excel very simply. It's already a built-in function that we can write. So in Excel, if you want to write any equation or you do any calculation that relates to matrices, it starts with letter M. So it's M, and then I want to calculate the determinant, so it is M determ, and then we can select the array, which is this matrix, and by pressing enter, so determinant is 0.042. It's not 0, luckily. So these numbers have, or these equations are all independent. We have no two dependent equations in this determinant. Now we want to go to the next step, which is the calculation of the inverse of the matrix. So I already have here a space for the matrix inverse. I just put it here just to make things easier. So to calculate the inverse, we have to highlight 17 rows by 17 columns, and we write equals. Again, it's matrix operation, so it starts with the letter M, and then I want to calculate the inverse, so it's M inverse. And then we highlight this matrix. And there is one thing that you need to remember, that you have to not press enter. So you have to press Control, Shift, and enter. You have to click on the 3 together. If you do this and you calculate M inverse of this matrix, and you click enter, well, yeah, it seems that the new versions of Excel have solved this issue. So you don't have to calculate to click on the 3 buttons. Just enter is enough. So this is the inverse of the matrix. So just one thing before we skip this, or to move the next point, I want to show you that the determinant, the number that we have here, can be negative, can be 0 if there are 2 dependent equations. So for example, if I put this instead of the coefficients here to be the second or at NB2 and NB4, I will repeat the first equation. So I'll put it as let's say 3 and negative 3, and I'll put it as 0. So if I put this 0, then the equation or the matrix would be the same as the above matrix. It's just multiplied by 3. So if I put this as 0, the determinant is 0 because we have 2 dependent equations, and it's going to give you an error. So it cannot calculate the inverse here. So this is what you get. Okay, number is an error. It's telling you that something is wrong. And what is wrong here is that you cannot calculate the inverse of this matrix because it's a singular matrix. So the solution is, or this is one thing that you can do to make sure that you have an inverse, which is the determinant. So you see, if I just change any of these inputs here, the matrix will have an inverse. So now I return it back to the original form, and now we want to go for the last thing, which is the calculation of the X matrix, which is the variables. So we agree that it's going to be the inverse multiplied by the product matrix or the output matrix. So we will highlight this again, and we click enter. Or type enter. Again, it's a matrix operation, so it starts with letter M, and then it's multiplication, so it's MULT, so it's M multiply. I choose this matrix, and I choose this matrix, and then close the bracket, and here it is. So now we are done. These are all the variables that we have. Or the outputs that we have. These are the results. These are the number of moles of Ne5 and Nb5, which are the products. We have here the extent of reaction. We have the flow rate of the feed to the reactor. This is the flow rate of the feed or the product of the reactor. This is the top product or the recycle stream. This is the final product. And if you remember, if we go back to the flow sheet, there are things that will make sense now. So we have, for the overall loop, we have 500 moles of inert, so the number of moles of inert and the product must be 500, which is 500 already. Okay, and there are a lot of things that you can double check. You can do any balance on any unit and check the numbers. But this is one way of doing the solution. You'll notice, of course, that this method is a very good method to do this, especially with the software, because now you have a very efficient tool that can help you do all the calculations in few minutes. But of course, writing the matrix is big, especially if you have more variables, and if you have 25, 30, 40 variables, then it's going to be a hectic process. Besides that, there is a very big chance that you will do some mistakes while writing the numbers, and tracing the error or tracking the error is going to be a long process. And the other thing is that this is valid only for, or this method of matrices is valid only for linear algebraic equations. So if, for instance, you have any additional relation that is kind of non-linear, then this method is not going to be a valid method to do the solution. But it's very good. It gives you everything, and it gives you the exact solution. So this is the numbers that you have here are the exact numbers that you will get if you do the calculations. So this is the first method. I hope it's useful. I think it's an interesting way of doing the calculations. And next time we will see the other method, which is what we called here the tiering technique or the tiering strategy. So I'll see you then.